Do not eat using your hand or using a spoon. Rather, eat automatically with just 30 lines of Python. And if you watch till the end of this video, you will see the craziest thing of your life where I would be just opening my mouth and food, drinks would be automatically coming to my mouth. And this crazy thing is done with just 30 simple lines of Python. So let's get it started. Before getting into the detail, please like this video and subscribe to this channel. Otherwise, Elon Musk will kick you out from Twitter. To start with this fun project, you will definitely need Python installed in your computer, and I would be using a Python code editor called VS Code, and definitely I have Python extension installed for this editor. And if you want to just create a new file, all you need to do is to click on new file and select the file type Python and press Ctrl S and save it somewhere. So I would be saving in my Python course and create a folder automatic underscore eating, because we would be eating automatically, and that's the fun part of this project. And I can give some fancy name for this file, or I can just name it main.py, and my file is ready. And after that, I will press Ctrl J to install some packages. And here I would be installing 3 different packages in my terminal. For that purpose, pip install. The first one would be open cv contrib -python, and the second one would be the very powerful media pipe, and the last one, for make our project real world applicable, we would be using PySerial, and that's the surprise part of this project. So these 3 packages is installed for this project, and the first thing I would be using in my first step is to open the camera, so that camera can detect my face, can detect whether I am opening my mouth or not, and once it detects my mouth, it would be automatically giving food or drinks and a lot of cool stuff. So the first step, just import CV2, which is just open CV. And the second line is to open a camera, and for that purpose, CV2 video capture, and you will pass a number. In my case, I will pass the number 0, which means the first video capturing device for my computer. Then, since I would be capturing the video again and again, I would be running a loop, and for that purpose, while true, that means this loop would be running forever. And after that, I will just need to capture the frame from the camera, and the first parameter I don't need it, that's why underscore, and second one would be the video frame, and that's what I would be getting from the cam variable that I declared in the line number 2, and then I will read the camera feed. The next line is to display the video, and for that purpose I will call CV2 and to do some image show, that is IM show. And IM show needs 2 things. The first thing is the name of the window. I would be giving the name, what I would be doing is automatic eating, and the cool thing. And the second parameter is the frame. And the last line I just need is to CV2 and wait key. So CV2 will wait 1 millisecond for any key to be pressed. That's it. With just 6 lines of code, you save this file and click on this run button, and it will open a camera for you. And by opening the camera, our first step would be done. You see the camera? That means the video capturing is done. Our step 1 is done with just 6 lines of code. Our next step is to another 7 lines of code where we would be detecting the face. So let's get into the part number 2. In this part, we will be importing another package that we just installed, and that is our media pipe. We can give it a shortcut name like MP. And after that, we will need to detect the face, because without detecting the face, you would not be able to detect whether I am opening the mouth or not. And for that purpose, I will declare a variable called face mesh. And we will go to MP, and it has so many solutions. We need the face underscore mesh, and inside that there is something called face mesh. I will need this dude. And once you have the face mesh, the second part is to need to convert the frame to some RGB mode. So we can easily convert it by using CV2. So it would be call a variable called RGB frame, and this would be CV2 convert color, which is CVT color. And the first parameter would be the frame that we want to convert, and second one would be we will call CV2 to give us the color. So it will give us the color, and that color would be BZR to RGB. And once we have done this, after that we can use this RGB frame to process the video source to detect different parts of the face. And that's the powerful thing would be done by media pipe. So we can tell it this is our face detected. So we'll be declaring a variable called output is nothing but by calling this face mask. So we'll call this face mask and we'll tell to process the RGB frame. So we'll just call and then pass this parameter RGB frame. Once we have the RGB frame, we will be able to get the face landmarks in every important point on your face. And that's why we'll declare another variable called face landmarks. And this would be coming from this output variable, and from that output we will get multi-face landmarks. That's it. If you want to see why the landmarks are generated, you can simply print those face landmarks. It generates a lot of points on your face. So make sure you save this file and then press this run button. It might take few seconds to open the video, and once this video is generated, you would be able to see the landmarks of your face, the location of the face on this video. So that's how we will be done with our step number 2. So our step number 3 is just to detect the different landmarks on your face so that we know which two are your lip, and by using that we will be able to tell whether you are opening the mouth or not, or closing the mouth. And that part is super easy, my dear friend. You already got the face landmarks. We'll get rid of these two, and with just another 6 lines of code we would be able to get all the landmarks on your face. So just for the safety purpose, we can check the face landmarks, and inside the face landmarks we can get the face. And that would be, for example, it would be the landmarks of the face. And when you get the face landmarks, you will notice that we are getting the multi faces. And here, since I have only just one head, that's why this would be the first one. And from that, I will get all the landmark on this face. And once you get all the landmarks, all you need to do, find out the position of each landmark and draw a circle. That's super easy. And we can run a for loop, say for landmark in landmarks. And if you do this for every landmark, you will get the position x and y. And we can get x equals to landmark dot x. And you can get the y position, the y-axis position would be landmark dot y. And after that, you can just print out x and y. And we save this dude and run this guy, and this will print so many different points of your face, and you will notice all the coordinate is just some fraction of a number. To plot actual circle, you will need a pixel number. So all we need to do here is to whatever the fraction of point we are getting here, we need to convert it to the pixel of the whole axis. And for that purpose, we will get the whole width of this frame and the whole height of this frame. And we can easily get these two. And we will just close this guy, since we have the frame here, and somewhere around here we can get the frame width and frame height. And for this purpose, we'll get a variable called frame height, and the second one would be the frame width, and the third one we don't need, and that would be from the frame dot shape. That's it, we'll get the frame height. And we can easily multiply the landmark with, this is the x-axis, that means we will multiply it with the frame width, and y-axis, the vertical axis, would be multiplied by frame height. And now if you save this guy and run this dude, and you will get some higher number which is bigger than 0, but they are not integer. And if you want to convert those number to an integer, you would be easily able to convert those, because you see those are some fraction decimal number. And to convert it, all you need to do is to just wrap this dude inside parenthesis and pass it to the int function. Here you have the int function, pass the whole thing to the int function. If you have done this, you will see that every point here is an integer, and that how it would be much easier for you to draw a circle on the face. And drawing the circle is super easy. So we'll get rid of this print and we'll call CV2. You need to draw a circle. And the first thing it will need where it wants to draw the circle, and that would be the video, our frame. So we'll pass the frame to it. And the second parameter is the center, and center would be our X and Y. And the third parameter needs the radius of the circle. We'll just pass 3. And the fourth parameter would be the color of the circle, and this is like BZR color, and you can pass say 2550. That means you want some green color. Save this guy and you'd be able to detect your face by using Python. This is a super powerful package, the Media 5, that was developed by Google folks. So we started running this guy, and let's see whether we'd be able to detect the faces. And you see, all the landmarks of the faces is detected. We don't need all these landmarks. We don't need like eye and forehead or the lip, all these things. We just need 2 points. One is the upper one and another is the lower one. And we can easily get that. And to do so, in here we need to do is to convert this to an enumerable. So we just wrap it around and enumerate. And once you pass this enumerate a list, and it will give you 2 parameters. One would be like the ID, another one would be the landmark. And by using the ID, you can detect. So for example, if the ID is equals to 0, that means this is your upper lip. And in that case, you will just draw the circle for it. I just indented this guy. Another one, I can just, if ID equals to 14. Okay, let's do this one as well. In that case, I can just copy this line and then here paste this to it, and maybe I will give a different color. Maybe this is BZR. That means this would be green and this would be our red. So pass this to 55. So that means if I am having here this upper lip would be our green circle and red would be our lower circle. So let's see whether we can detect the upper lip and the lower lip. So we are waiting for this Python to show us some magic. We would be able to detect the lip. And if we can detect, you see, if you notice a little bit cautiously or pay attention here, you will see that upper lip, if I keep my mouth open, you see there's a small circle over there. And if you look into the lower lip here, you will see another circle. That means I can detect the upper lip and lower lip. And if you can do this, it's super easy. If the gap between these two lip position is higher, that means mouth is open. If the gap between these two lip is smaller, the mouth is closed. As simple as that, right? Super easy. So all we need to do is to close this guy and get the Y coordinate for all this. And we want to save this too. And for that purpose, we will declare a variable just before the loop. And that could be upper lip and then Y position. The initial value is 0. And second one would be the lower lip, the Y position, and that would be another default value would be 0. So we declare 2 variables. Once you detect this is the upper lip, in that case you can set this is upper lip Y is equals to the value of Y. And similarly, you can set this is lower lip value is equals to Y index. Whenever you are getting ID 0, that means you are getting upper lip. And in that point, you are setting the Y coordinate point to the variable upper lip. And whenever you get ID 14, which means you are getting the lower lip. And at that time, you are setting the value of Y to the variable lower lip. And you can easily get the difference these two. Since the coordinate is starting from the top of the screen, that means the upper lip has a lower coordinate number and the lower one will have a higher coordinate number. You can check these two. Say you will go one line down and backspace. You can print here. You want to print like, say for example, we print like an upper lip and then lower lip Y. You can save this guy and then you can run this two. In that case, you will see that the first number, which is our upper lip, has a smaller number and lower lip has a higher number. But that's not important here. All we need to do, you see, this is a higher upper lip and this is the lower one. And if I open my mouth, this number increases significantly. And we can easily get the difference between these two. And say for example, if we want to get the positive number, in that case lower lip is a higher number, so we can just type lower lip minus upper lip. In that case we will see a simple pattern very easily. If my mouth is open, number is higher because the gap is higher. If mouth is closed, number is smaller. So let's see, this guy is running and you see mouth is a very smaller gap. You see higher gaps. That means you can write easily a condition that if the gap between these two is higher than any number, say for example higher than 21 or 20, then your mouth is open. And we would be doing that in our part number 4. And we would be doing this fun thing in our step number 4, and the craziest thing you will see is step number 5. So now the fun thing, and we already know the difference between our upper lip and the lower lip. So we can just convert it to an if these two is greater than 20. In that case, we can easily tell, or we can just print your mouth is open, mouth open. And otherwise, we can say like an else, print mouth is closed. So mouth closed. This is so easy, right? And if you just test it, you can click on this tool. It will open your video camera and you will change your mouth and you'll see the print at the bottom that it's telling whether mouth is open and closed. And this video started, you see mouth closed. It's pretty close, right? So if I open, it's closed, right? This is the cool part of it. And since we can easily detect mouth open or mouth closed, we can send a command to a real device to do all this cool stuff. And I have some powerful Arduino Uno, and we'll be demoing a real world project where I would be automatically eating in the crazy step number 5. But before going there, we already have Pi serial installed, so we can easily import serial from Pi serial that we installed, and there we will need an Arduino commander. So we can just declare a variable Arduino. We can name anything, but I'm giving the Arduino commander, and from the serial I will call the serial and then pass two things. The first one would be the serial port, which would be COM3, and second would be the rate, how frequently it will communicate with your computer and with this Arduino. And we got this part. And last two line is to whenever your mouth is open, you will send a byte, a small string, 8-bit string to the Arduino. And you can easily do, this is your Arduino commander to write, and there you will if pass like O, but this is a string. So if you put a B in front of it, this would be a byte data you would be passing there. Similarly, when your mouth is closed, you can easily pass Arduino commander and then you write a small byte. This should be C. That means this is closed. That's pretty much all you need to do from here. And if this needs to be connected with your computer by using some printer cable or USB type B, and you can easily connect it right here by using this. And if you just connect here, you'll see some light is blinking on your Arduino Uno, if you can just look into this. So we'd be demoing a real world project. I have a few parts here. The next part, I have some USB motor. This motor would be powered by opening the mouth and do some crazy thing. I have a battery to run this motor. I have some extension cable to connect this battery, and last thing, I have a motor driver shield. So this is the shield where I connected a battery connected cable. You can connect here, and then I have this USB motor driver connected, and you can connect it pretty much anywhere. So there are 4 different slots, M1, M2, M3, M4. I connected with M4, and if you need it, you can use some screwdriver to just loosen and connect. And I will definitely put links to these parts in the description below. Also, you will get the link to the source code over there. But our crazy part is to connect our Arduino Uno, and we will have a real demo. And I'm very excited to show that part. Now we will do the craziest part of this video. And for that purpose, we would be actually running our actual real world demo of automatic eating using this Arduino Uno. And since we have the Arduino Uno, we will need to connect this Arduino Uno by using this USB type A. If you have a printer, you know what is this cable look like. And by using this, you need to connect with Arduino Uno. It has just only one port. If you connect it, you will see the light is LED. That means it is connected. And also you will need Arduino IDE. So I have Arduino IDE. You can just Google it and install it. And to make sure this is working correctly, the first thing you need to do, go to the file, and then you can go to example, you go to the basic, you will see blink. This blink, you can close the other window. It opens a new window every time. But anyway, what this code has is a two-part. One function is called the setup, another function is the loop. So the initial part of Arduino is like connecting or doing something, and then the loop is doing again and again, again and again. The code inside the loop is saying that I want to have digitally write something, the LED button, and then here it will be high. That means LED, whenever the light is high, that means it will be lighting, it will be on, and it will wait for 1000 milliseconds. That means for 1 second. And after that, light would be low. That means it would be dark. And to test it, make sure you have this COM3 is set up, and you click on this guy to upload whatever the code to your Arduino. And if this done completely, you will see a light here, and you will see this light here which is blinking. That means on for 1 second and off for 1 second. And if you want to test it even more, you can increase this number. For example, you can increase this for 5000, and then you can save this guy if you want to, and then click on this. That means the new code would be uploading here. And if it's uploaded, you will see the light is now turned on for longer duration, 5 seconds, and then it turn off for just 1 second, and then come back again for 5 seconds. That means you are successfully able to connect your Arduino Uno with your device. And then you will need a special program or a special package to connect with your motor shield. And first thing you need to do, go to your tools, and then you will see manage libraries. Here you can search for motor shield. And in that time, you will see a Adafruit motor shield. You can install whatever the version it has. I already have installed, but if you most likely don't have it, and you would be able to install here. And I will list all the parts I am using for this demonstration, so that if you want to try it yourself, you would be able to do it. So once we have this, all we need to do is to use some packages. You can definitely Google some of the packages here. So for example, I have like here AF DC motor. So you can search for Adafruit, which is AF DC motor class, something like this. And if you go there, it will give you the detail what you need to do. So if I go there, so like here, the first thing you need to do is to include Adafruit motor H. You can just copy this line if you are lazy like me. And here you can just put somewhere, not inside comment, but somewhere here, you can just include this motor. And from this motor, you need to create a motor, and you can give any name here. So here you will see like they have like FE DC motor, they give a name motor or whatever. In our case, we would be connected with a pump, that's fine. And then which port it is connected. If you look into here, you will see there are 4 different ports. And this is like M1, M2, M3, M4. I'm connecting with M4. So for that purpose, what I will do, I can just copy this line as well, and make sure you copy the semicolon as well. So here I will create a motor, and then I can maybe name it motor 4, or since I have just only one, I can just name it as a pump. And after that, all you need to do is to do some work. And the first thing, you need to set the speed. So here, once you have this setup, so I'm not doing like a LED lighting thing anymore. You need to do 2 things here. The first thing you will need to do is to pump set speed. So we'll say like whatever the pump we have, and we want to set speed. And the speed is something between 0 to 255. Make sure you put semicolon. And here you will see like a speed 0 to 255. 255 is like motor is running with full speed. So we set it up there. And the second thing is we need to connect with our computer to read some data. Whenever I am opening the mouth, the data needs to come here. And for that purpose, you will call the serial and then you will say begin and you will see some rate. This would be 9600. That means that frequently it will connect with the computer or the input device. And after that, inside the loop, we are not doing this blinking, rather we are doing even better stuff. And inside it, first thing you need to do is to read input from the device. And for that purpose, what we will do, we will say like an while your serial dot available, and if this is 0, in that case all we need to do is to read what it is providing. And I can declare a variable character, it could be command or whatever the name I want to give, and equals to the serial, and I want to read from the serial. So make sure you put the semicolon. Okay. And after that, all you need to do, if this command is equals to O, because from the Python side, you are sending a byte O. And if this byte is O, make sure, okay, I didn't put like a semicolon here. This will give an error if you don't put a semicolon, and you can fix it if you want to. But anyway, if the command is O, in that case, you can tell the pump, hey pump, you need to run which direction? Forward direction. And if you look their code, in their examples, you will get this one as well. Here, if you scroll down, run command, forward means the motor is running in the forward direction. There is a backward too, and release means stop the pump. So in our case, if you are sending us O, that means your mouth is open, pump would be running forward. And else, what it will do, we will just release the pump. Pump, run, release. So this would be release. And make sure you put like semicolon, make sure you put like semicolon. So once you have done this, now your task is to upload it to this Arduino Uno. And before doing this, you can do one or two things. So make sure you mount this, your motor shield on top of your Arduino Uno. And make sure you don't do it a crazy job, otherwise you might break one or two pin. So I am very careful, and then I'm putting there, the looks aligned. So I am putting this, and these two looks connected. And if it is connected, you will see this light is turned on. And to run the motor, I need to connect the battery. So I will do connect the battery with this cord. So I'll push it all the way down there. So I have this battery here, so in my one hand, and this is the other motor. So, and I already uploaded it, right? If I not, then I will do upload it again. If I have missed any semicolon, it will give error right here. But anyway, and once you are done uploading, you need to turn off the, close this Arduino IDE. Otherwise, this will be holding this, your COM3 port, and Python would not be able to send the command. So I will just close this guy. If I need it, I will open this again. So if you want to save it, you can save it somewhere. And in our case, it would be the Python projects and inside automatic eating. And here we can give some name. This is like a pump code or something like that. And we can save this dude. That's bye-bye. And then we come back here and make sure you have everything here, and then click on this dude. And now this is our final, this is our dry test, and we will do actual real world demo test after this. But I'm still nervous for this one. So this is, mouth is closed. If mouth is open, this motor should start at least running, and you should hear some sound. So open the mouth. Can you hear the sound? I'm trying it again. That means if I open the mouth, if you want, you can decrease the gap in between. But if I open the mouth, the motor runs. If I close it, motor is closed. That means we are successful with our dry run, but we want to do a actual real world fun demo, and we'll see it in a minute. The fun part is that all you need to do is to open your mouth. If you open your mouth, the food, that could be a drink or a granular type food, will come through the pipe to your mouth, and you would be able to enjoy it without holding or touching anything. And so let's give it a demo. I click on this thing. My mouth is closed, so there is no drink on my mouth. And if I Now the programming is running. If I open my mouth, you will see like drink would be coming to my mouth. You can also like if you don't want to eat all this food, you can just hold it here and you can see if you open your mouth, you need to ensure that you have like enough drink that covers the pump. So if you covers the pump and then you hold this nicely, that means by using your mouth, you should be able to eat like this. And that's how you can eat automatically without doing anything. So by looking at me, you know that this is totally work. You can automatically open your mouth and eat without pretty much touching anything. If your mouth is open, you'll be able to drink. So if you have watched until this point, please like this video, subscribe to this channel, and also if you want to learn Python in a fun way, go to the App Store, go to the Play Store, find a fantastic app called Programming Hero.